In our lesson today, we talk about radical denominators. Okay, denominators, that's the bottom part of the fraction. And remind me, what are we talking about when we talk about radicals in math, Abby? So roots, specifically square roots, are what we are going to talk about. Now, wait a minute. Haven't we talked about square roots and denominators before? Haven't we already talked about ones like this? Remind me, what do we do with one like that? What do I have to do to fix that one? Ada? Perfect. Since we have a square root in the denominator, we multiply numerator and denominator by that. And we get 5 root 3 over root 3. Root 3 is just a regular 3, right? Well, we've already done that. What about one like this? Are fractions okay to have? Square root of a fraction? What do I need to do? I don't know how to do the same thing yet. I don't have a... Okay, break it into square root of numerator over square root of denominator. Hey, this one's easy, right? Because that square root comes out nicely, and then I don't have one in the denominator. And if it hadn't been a nice number like 16, I would have then had one more step of what I just did. Okay, what about, oh, wait a minute. Have we done ones like this with a plus or minus? That's what we're talking about today, when we have a square root and a denominator, but we have a plus or minus. So maybe we should call this more on radical denominators. And I don't know about you, but the first thing I would guess, if I'd never done one of these before, I'd try, well, let's do what we've been doing. Let's multiply numerator and denominator by root 5 and see if that helps us. So if I do that, since that denominator had a plus or a minus in it, I have to think about it with parentheses around it, so I can multiply denominator times denominator. So my numerator would become 7 root 5. And let's see if I get rid of the square roots in the denominator doing this. Root 5 times 2 is 2 root 5 plus root 5. Root 5 is a... Well, I got rid of 1 root 5, but now I've got a root 5 in the other part of it. That didn't work. So I'm going to have to come up with something else to do. So we'll come back to this one in a few minutes in our notes and finish it up with a method that actually works to get rid of the square roots in the denominators. First, a vocabulary term. If you have a binomial, which means you have 2 terms in there, they may be numbers, they may be variables. The conjugate is you keep it exactly the same, except you only change the plus or minus sign in the middle on it. So if I have x plus y as one binomial, the conjugate, the only thing I'm going to change that plus sign in the middle to a minus. But I'm going to keep the x and the y just like they are. So let's first practice just writing down some conjugates. If I have -4 plus root 3, that has 2 terms. Conjugate is going to only change the plus or minus sign that's in the middle. It's not going to change anything else. So I'm going to keep the -4, and I'm going to keep the root 3. All I'm going to do is change the plus sign in the middle to a minus. Allie, what would I do for the next one if I wanted its conjugate? Perfect. What if I had a minus b? What would I do in that case to get the conjugate? What am I going to do there, Caleb? Perfect. So now that we know what a conjugate is going to be, we're going to practice multiplying one number times its conjugate. So that means I need to take the -3 plus root 7, and I need to figure out what its conjugate is, and then I can multiply them by each other. So what am I going to get for this conjugate, Austin? Three minus root 7? Almost. The only thing I want to change is the plus or minus sign in the middle. So -3 minus root 7. Okay, now I have a parentheses with two things times another parentheses with two things. So I have to FOIL. So if I do that, -3 times -3 is +9. Then I get negative times negative, which is a plus 3 root 7. Now for the inside times inside, plus times minus is a minus, a 3 times a root 7. And last times last, plus times minus is minus. Root 7 is a regular 7. What do you guys notice about the two middle ones? They're going to cancel out. Hey, I just got rid of all my square roots. I think I'm liking what's happening here. All that's left is I have to put the 9 minus 7 together to get a 2. So that tells me if I have a square root in the denominator with a plus or minus in there, if I multiply that denominator by its conjugate, I get rid of the square roots. But I'm not going to be able to just multiply the denominator. I'll have to do numerator and denominator. So we just did -3 plus root 7. That's now my denominator. I just figured out that if I multiply that denominator by -3 minus root 7, the square roots are going to go away. I also know it's going to be 2, but I'll write the work down again to make it look more like a problem when you do it. But I can't just multiply the denominator. I have to multiply the numerator also. Okay, numerator's easy. 1 times that parentheses is -3 minus root 7. Denominator, we've done the work, but I'll write it down again. -3 times -3 is +9. And then I had a +3 root 7, and I had a -3 root 7. And when I finished FOILing, last times last, plus times minus was minus. Root 7 was a regular 7. And we already saw that those two with the square roots canceled out. So that means we can write that our final answer is -3 minus root 7 over 9 minus 7 is going to be 2. Does anybody have a question on that? Okay, let's go back to that one that we had on the board at the very beginning, and we tried something that didn't quite work for us, and see if now we can get rid of it, get an answer that has no square root in the denominator. So we tried before multiplying numerator and denominator just by root 5, and that didn't work. So Ethan, what should I multiply numerator and denominator by now? Minus root 5. Everybody good with that? That's what the conjugate. So we need to multiply numerator and denominator. And whenever we're multiplying things with a plus or a minus, we need parentheses around them, so we make sure we multiply the complete thing. So now my numerator is going to be 14 minus 7 root 5. My denominator is going to be 2 times 2 is 4. And now I'm seeing that the middle ones are going to cancel out. So write these if it helps you, but you don't have to write them. If you can say, oh, I'd get -2 root 5 and +2 root 5, they cancel. Maybe don't even write them down. But then don't forget last times last, plus times minus is minus. Root 5 is a regular 5. Thumbs up, thumbs down. Are you with me to that point? That means my denominator is now a -1, no more square root. This is working. And the denominator is 14 minus 7 root 5. However, if it is just a number in the denominator, we don't want it to be negative. So if it is just a negative number, we're going to do what we talked about yesterday and multiply, put the minus sign with 2 of the 3 places on a fraction. So we are going to take the denominator and make it be a negative, and we're going to put another minus sign on the numerator. so that then we have a plus 1 in the denominator and a negative 14 plus 7 root 5 in the numerator. But then we don't just leave a denominator with 1. Anytime we have something divided by 1, we write just the numerator. So negative 14 plus 7 root 5 will be our final answer on that one that we started off with on the original title page. So let's do one last example, because I'm going to make this one be a bit messier. Have one or two extra things to think about in it, but so far so good. Okay, final example of the day then. Okay, so I've got square roots in the denominator, but messier than what we looked at before. Now I've got 2 square roots, and I have a number times one of those square roots. Still the same method. Multiply numerator and denominator by the conjugate. That means I take this thing with 2 terms, the 3 root 2 plus root 3. The only thing I change is the plus or minus sign in the very middle. Everybody good with that would be the conjugate. Just changing that middle plus or minus sign. If I multiply the numerator, I must multiply, if I multiply the denominator, I must also multiply the numerator. And since these have pluses and minuses in them, we'll put parentheses around each of those. So now when I distribute the 5, I get 15 root 2 minus 5 root 3. Denominator, when I multiply first times first, and you have to be a little bit careful when you have a number and a square root. That means I have 3 times 3, and I have root 2 times root 2. The 3 times 3 part is a 9. The root 2 is a regular 2, so that's going to end up being an 18. Then I have, write this if it helps you. If you want to just think it through that they cancel, that's okay. Plus times minus would be minus 3 root 6. Then I would have the insides. Plus times plus is a plus. And I'd have the 3 root 6. Like I said, you can write those or not, because we've been seeing when we multiply by a conjugate, those are always going to cancel. And then to finish foiling, last times last, plus times minus is minus. Root 3 is what? Regular 3. That means my numerator is 15 root 2 minus 5 root 3. And 18 minus 3 is how much, everyone? 15. Now, as you look at that, what do you notice? We aren't finished. Why not? What else can we still do on that? Why is that not my final answer? Why? Okay, everything is a multiple of 5. So let's factor a 5 out of the numerator, which leaves 3 root 2 minus root 3 over the 15. Still not done. Why not? Now what do I need to do, Cooper? So I always look at the fraction part. Can I reduce it? It reduces to 1/3. So I'm going to have 3 root 2 minus root 3 over a 3. Now, what you guys were saying, it reduced to 1/3, but we try not to write just a single 1 in front of something. It just makes it longer and more involved than we have to. So that 1/3, we don't need the 1 in front of a parentheses around all of that. It's implied. Questions, anyone? Then we're going to work on homework.